Class, we're back again, and now we're looking at example 2 from chapter 8.2, and that is connecting rates to contextual situations. So, what we're trying to do is we're going to describe a situation in which each unit rate might be used, and we're going to identify and explain factors that could influence the unit rate in this situation. So the first example I really like. You guys are always looking for contextual applications of mathematics. This is largely based, if I was to speculate, this is largely based around medication and the idea that how much medication you give a person typically depends upon their mass. So this could easily be for assigning medications. I know that I have a lot of nurses in my family and they do calculations like this all the time. So for example, let's just say we had an 80 kilogram person and we were trying to figure out how much medication we need to prescribe to them. So we would set up our conversion factor. We would set up kilograms in the bottom. We would set up milligrams in the top. So we've got 1 kilogram here. I should apply 0.05 milligrams of medication. It's a quick multiplication, so I'll do 80. I'll do 80 multiplied by 0.05, and that gives me back 4. So I need to give this person 4 milligrams exactly of medication. And so that's a great real-world example. The next one could obviously be another real-world example. If you watch the previous video, this looks a lot like a rate for gasoline or fuel. And so something you might consider is like, hey, my tank holds 55 liters. I think that's about what my personal tank holds. And so I could use this to figure out, hey, at this price, how much is it going to cost me to fill up? So I would take my liters on bottom, so I can get rid of my liters unit, and leave me with cents up top. And if I look at this, I've got 1 liter is equating to 98.5 cents. So again, a quick multiplication, 55 times the 98.5, and it looks like it's going to cost me 5,417.5 cents. So 5,417.5 cents. For a more kind of applicable situation, you could change that to dollars, dividing through by 100. You get $54, and basically let's round to 18 cents. Okay, so that's what you would end up to fill up your gas tank. The last one obviously relates directly to, say, like a download speed. And I don't know if anyone's ever mentioned it to you guys, but this is actually megabytes per second. So if you were trying to download, say, a film that was 100 megabytes, you're trying to download that film that's 100 megabytes. And so you want to know how long is it going to take me? Well, your rate is 7.2 megabytes for every 1 second. So again, a quick multiplication. Multiplying by 100 is just going to move this decimal over twice, and it's going to take us 720 seconds. If you wanted something more applicable, you could take this and divide it by 60. So taking 720, dividing it by 60 gives us back 12. So it's going to take exactly 12 minutes. And so there's an easy way that not only you can apply rates to contextual situations, but you can also see how I use those to answer questions about them.